Welcome to Train Signal. I'm Mel Haynes, and in this video we'll be looking at performance tuning your SQL Server environment. So what are the tools we'll be looking at? And there is a nice sized list of tools. First of all, I'm going to introduce you to the SQL Server Profiler, and we'll use that to create a trace file and then analyze that trace. The primary tool we're going to use for analyzing it will be the Database Engine Tuning Advisor. We'll look at query analysis. Now, I've said this a few times and I'm going to say it again, and that is the query analysis process is more developer tasks than an administrator task. However, as an administrator, you will still want to be, one, familiar with the tool, and two, able to at least start to identify some problems in your environment so that you can hand them off to the appropriate person. And then last, I just want to reiterate some performance tuning tools that we don't cover in this video. I cover them in a separate video, but I wanted to mention them again here simply because they could easily fall under both titles, monitoring as well as performance tuning. The Microsoft SQL Server Profiler is a tool that will capture the activity that's occurring in your SQL Server environment as it occurs, and you can save that information to a file. You can save that information to a table within a database as well. And you can also step through queries one line at a time using SQL Server Profiler. You can replay events later on to do analysis on them. So it's a pretty clever tool. What we're going to do, we're going to actually pair it with another tool. But before I get to that, here let's talk in a little more detail about what SQL Server Profiler can do for you. First of all, as I said before, it can actually step through your queries for troubleshooting. You can use that to then identify queries that are slow. You can capture information from your SQL Server environment called traces, and then you can use it for analysis as well as for replaying it. And here's where we're going to actually jump into in a moment, but you can take the output from the SQL Server Profiler and use it as input into the Database Engine Tuning Advisor, and then the Tuning Advisor does just what its title says. It actually gives you advice on what you should do to tune your environment. Another key thing you can find with the SQL Server Profiler is it can help you figure out where you're having problems with deadlocks, right? Where you have one process that's waiting on a resource and another process is waiting for that first process to finish, but the first can't finish because the second actually has the resource. So if you're familiar with this, the classic deadlock scenario, there's nothing really new there, but it's the SQL Server Profiler that can help you find those and identify those. Once you get into the SQL Server Profiler, you have a huge list of configuration settings that you can tweak and toy with and play with and change. Actually, I have so many that for the average Joe, if you just sat down and started using it off the top of your head, you'd probably not have a clue as to where to start, no matter how much reading and background you've done. You really want to have some time playing with it and seeing the results. Well, to help speed up the productivity of the tool, it comes with pre-built configuration templates. So you can choose from a list based on the type of thing you want to analyze. I'm having problems with my deadlocks, or I'm having problems with query performance, or whatever the area might be. It will give you an option to choose in a drop-down that you can customize if you like, but it already contains the core settings and the core measurements that you'll need to zero in on the area of interest. Now, before we get into demoing the profiler, I want to talk a little bit about the Database Engine Tuning Advisor, because we're actually going to look at both of these at the same time. So it's the Tuning Advisor that, as I mentioned a little bit ago, it actually helps you automate your SQL Server optimization. It gives you recommendations as to, hey, add an index or remove an index, or actually here's a list. Indexes. It can tell you to add one or delete one, right? Let's say you've got an index out there that you really aren't using, but because it exists, every time you do an insert or an update or a delete, you have to also update your index, right? So if it's not giving you any benefit, you definitely don't want it out there because it's going to cost you as far as simply maintaining it. Adding new partitions. Database Engine Tuning Advisor can give you advice as far as adding new partitions, as well as adding statistics. Now, statistics you won't necessarily interact with directly. Well, neither indexes either, but statistics are something that SQL Server itself will use to optimize queries. It looks at the history of how things have been running in your environment, and based on that it can optimize your queries. Well, you can add new statistics using Database Engine Tuning Advisor, and it'll actually let you know when to add them and give you a lot of pointers on how to get it in place. This also comes with predefined configuration templates. It is completely customizable. One of my favorite features is right here. Not only does it say, hey, you should add an index, it actually gives you the T-SQL code for creating that index. So after running the Database Engine Tuning Advisor, all you have to do is say, hey, I like your suggestions, let it be. Click on the button and it'll actually run the T-SQL to add indexes, to add statistics. So it's really, really cool tool to work with. And as I mentioned before, the SQL Server Profiler output, known as a trace, is used as input into the Database Engine Tuning Advisor. And that's how it knows how to optimize your environment. So it's important that you have a workload that is as realistic as possible. Ideally, just turn on the trace while you're in a production environment, capture some of that information, stop the trace, and then apply the Database Engine Tuning Advisor. One word of caution with that, I mentioned how you can save the output from your SQL Server Profiler to a table within a database or to a file. I have had the pleasure of saving that information to a table within the same production environment. Bad idea. It will dramatically impact your performance. As you will see when you get into the profiler, it's generating just reams and reams of data. So if it's having to do that in addition to its normal production work, you will see performance hits. You want to typically have that information saved in a separate file, possibly, or preferably I should say, on a different drive. The Database Engine Tuning Advisor can also evaluate your queries and let you know how to best optimize them. And I'll show you that just quickly toward the end as well. But let's jump over to my server. And we're going to use the SQL Server Profiler first of all to capture some data on our environment. I have some SQL queries we're going to run that'll just do some work for us. And then we're going to take that output, that trace file, and we're going to analyze it using the Database Engine Tuning Advisor, and then use the output from the Database Engine Tuning Advisor to actually optimize our Veronica's database. So here, let's do that. So I'm going to continue on, kind of picking up where we left off with our previous example, where we had table scans that were consuming, it looks like, almost 60% of our total query. And we talked about how table scans were not the best way to go. But we're going to bring up our next tool, SQL Server Profiler, and I've been in there before, so it's already on my list. I'll go ahead and click on that. If you hadn't done that, of course, just go to All Programs, SQL Server, Performance Tools, and you'll find it right there, right underneath the Database Engine Tuning Advisor, which is what we're going to look at next. But first of all, looking at the profiler, we're going to use this to capture information about what's going on in our database so that we can then turn around and analyze it and have the Tuning Advisor automatically give us recommendations on how to optimize our SQL Server environment. But going to the first icon here, it says New Trace. So clicking that, it asks me first of all, what server do I want to trace, and I want to go against my current one, so that's exactly what's listed there. So I'll click Connect. Here on the Trace Properties screen, I get to fill in some important information, such as, first of all, what is the trace? And I'm going to call mine Veronica's order. So I'm going to do some tracing based on my order analysis or my order report SQL query that I did before. Okay, so I'll just give it a name. It gives me the name of the box I'm on again. Use the template. Use the template. It's currently defaulting to my standard template. The template tells me what actions within SQL Server do I want to trace. What do I want to record? You've got a long list of built-in standard templates. And actually here, the best way to get a feel for those, let's jump over to MSDN And I'm going to enter SQL Server Profiler Templates. Press enter, and looks like the second one on the list, SQL Server Profiler Templates. Bring that up, and here I can see the complete list of all the templates and what they do. So for example, the standard template, generic starting point for creating a trace, captures all stored procedures. T-SQL batches, used to monitor general database server activity, and it gives me a list of the actual classes that it's going to be looking at. It'll look at the login process, the logout process, anything associated with the existing connection, remote procedure calls, right, RPCs, SQL batch completed, and SQL batch starting. So basic stuff. If I scroll down a little bit, so for example, let's say I'm dealing with issues with locks. There's a T-SQL locks template that includes things such as a lock was canceled, a deadlock was incurred, deadlock chaining was incurred or occurred, lock escalation. So anything surrounding locks is automatically included with that one. So why do I need templates? Well, if you've seen the complete list of options you can choose from, it's pretty daunting. You can go in and tweak it and create your own templates, but typically for starters, for a while, going with the existing templates is going to give you 90 to 99% of what you need. But we'll see that in a little more detail. What do I want to do with this trace information? I can save it to a file. I can actually write it to a database. I'm going to go with a file. If I click that little checkbox, it pops up a name. It matched the name of my trace file, which is pretty cool. And it wants to dump it into the administrator documents folder. That's fine. It'll do for now. It'll have an extension of TRC. Nothing really special about that, but the other tools will automatically look for TRC. So I click Save. It actually goes out and creates that file for me. And then some other statistics are available. First of all, set maximum file size. It defaults to 5 meg, after which it'll start to roll over information. So if that's a concern, you could modify that to match your needs. So we could say make this 40 meg, right, or any size you want. Going to the second tab here, the events selection, here's where I could actually customize the template. It's the template that I selected that gave me this list of checked items. All right? If I want to see all possible events, I could do that from here. And once again, the list is quite daunting. There are literally hundreds and hundreds of different options you can choose. So thank goodness for some pre-built templates that give you a good solid foundation of information that you can use in your environment. But if you wanted to tweak it, jump in and do that. We're not going to do that for now. We're going to go with a standard default template. If I just click run, it's up and listening and tracking everything I do on the SQL box. So let's give it something to track. I'm going to go back over to the Management Studio, and I'm going to rerun this exact same query statement. Just hit execute. All right. Then jump back over to my profiler, and it has now captured information related to that SQL statement. What I'm going to do now is stop the trace, and the physical file is out there with this information in it. I can now analyze that using the Tuning Advisor. So if I go to Tools, Database Engine Tuning Advisor, it'll also ask for permission to access my server. Click Connect, logging in still with the same account. And I'm going to have it grab that file. So it's asking for a workload file. Or I could have, like I said, saved it in a table and pulled it back from that table. But browse for workload file, go to my documents folder, and there's the Veronica's orders trace. So I'm interested in tuning my Veronica's database. I'll go ahead and check that. And then click Start Analysis. I'll maximize that while it's processing. So it's running through that file and determining what changes should be made to the database to allow that same query to run faster. And there, I've got my 2 recommendations. If I go back to progress, I can see it successfully completed all 5 steps. And if I go to recommendations, I can see there are 2 to create 2 new objects in my database. The first one is a clustered index. If I scroll over a little more, I can see some other information about that index, such as the size it will take up. And then here's the actual T-SQL that will be used to create that index. If I just click on the blue hyperlink, it gives me the T-SQL. I can copy that to the clipboard and run it myself, right? Or I'll show you in a second how you can let it actually run it for you if you like what it put together. Now, one thing I might recommend you change in a production environment, notice the default names it's giving to the objects it wants to create. The first one was an index. The second one here is a new statistics. We'll cover that topic in a second, but for now it's just a new object that'll help optimize our database, right? So go back here. And I want to point out these names. It's creating a new index. Index number underscore DAT underscore index underscore order details underscore C underscore yada 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 yada, right? Not the most user-friendly name. So you might want to consider copying this to the clipboard, modifying the name, and running it yourself manually. If you don't really care, it's not that important, you could just run this directly from here, which is really cool. So you don't have to do anything other than tell it under actions, apply recommendations to add those two new objects. But before I do that, let's go back and talk a little bit about what is this second object. Create statistics. Create statistics. You won't use this directly. Well, you don't really use indexes directly either, but conceptually they're probably one step further removed from you even than indexes, because this is something that the operating system uses when it's optimizing your queries, determining what is the best possible path to get to your results. It dynamically does that on the fly, and it uses statistical information that it's been tracking using a create statistics object to do that. So it's recommending that I create that new object. So I'll close this. Just going to actions rather, apply recommendations, apply it now, or I could do it later, click OK. And I have successfully added those new objects to my database. Click close, and I'm just going to close the tuning advisor down as well as the profiler. And we're going to rerun that query and include the actual execution plan. So I'll click there, click execute, and let's see how it differs. So I get my same results. I'll bring this up a little, and notice I have an execution plan tab. I click on that, I can see the execution plan. And notice there are no more table scans. Those are gone. And instead, I'm only using my indexes, my clustered indexes in each case, that are now part of my database. And there's that cryptic name again. Underscore DAT underscore index, yada yada yada. Same thing here. Now in this database, just keep in mind, we don't have tons of data. So you're not going to see a huge performance change, and I don't have a lot of activity going on in this environment. But in a live environment where you've got a database, oh, say 1,000 times, 10,000 times bigger than this one, and another 500 to 600 users, this starts to make a big difference when you're looking up information via a clustered index versus a table scan. All right? The topic of query analysis actually tends to fall more in the realm of database development than it does database administration. It's really the responsibility of the person developing your applications to make sure their queries are optimized and that the queries are not causing other performance issues. However, you will hopefully be the first person to notice performance degradation in your environment. So as a result, you're going to want to at least be at a high level familiar with the tools that are used to analyze queries, and hopefully give some direction to the person responsible on where they should begin to look to optimize their queries. We'll look at two ways to analyze queries. This is the first, and it's using execution plans. And I should preface that. The second one, we're not going to delve into that. We're going to actually just show you how to get started with it. But I did want to walk you through at least one. So let's move over to our server, and we want to look at using execution plans for query analysis. But let's go ahead and bring up a piece of code. If I go to File, Open, File, And I've been in here recently, so it's defaulting to that location. But if you go to your C course files folder, you have a folder under there called sample SQL. And I've just got some pre-written SQL statements, T-SQL, that you can use, so we don't have to sit here and write and debug that stuff. And if you go to the file called final order report, just double click that, and it'll open up some pretty simple T-SQL that's maybe a little clunky in that you would typically not hard code in values like this, but it gives us what we want to see. And that is something that's going to hit my database, give me some results, and then I can analyze the query. But first, let's just execute it. Make sure you're executing against the Veronica's database. And here's what it gives me back for results. 3 things. 1, using an order number, it does a backwards lookup to tell me, well, what customer is that for, right? Going into the order table, getting that customer number, gives me the customer name for that order, then gives me all the line items for that order by going to the order table and the order detail, and then I added at the end something to go through and sum up all this stuff. So what do I have here? 24 of these things, I'm sorry, $24 for 6 of these things, right? Bit of a difference there. 14 of these things at $12, and I get my subtotals and my total price. So something pretty simple. If you want to look at the SQL again, this isn't a SQL development video, but just wanted to give you a feel for what I'm doing there. All right, so just using a sum statement, and it gives me that value. Now what we're more focused on here, which is still outside of the realm of most administrative tasks, mostly this falls under the developer realm, but it's probably good to at least have some idea of what's available as a SQL admin. So going to the display estimated query plan, or display estimated execution plan rather, click that, and I have something highlighted. It doesn't like that. Click that and give it a few seconds. I'm going to get rid of some of these things to increase my screen real estate for you. Just close that down altogether. And it gives me an execution plan for each of those SQL statements, including the use Veronica statement, which has a total cost of not much of nothing, right? Which makes sense. But the second one, I have a select statement, nested loops, which is my inner join, and then over to the main 2 here, which is a clustered index seek and another clustered index seek here at the bottom. One over the PK orders, another one over PK customers. So I can see how my indexes, my clustered indexes, my non-clustered indexes are being used. And more importantly, I can see where most of my time or resources are being utilized. Notice the first 3 items there basically have a big fat 0 for costs. Only the last 2 have anything, and they both show 50%. So now in my database, I don't have a lot to worry about. It's not a humongous database. So the fact that 50% of my query execution time and costs was focused on a clustered index seek, well, 2 things. That's not bad because this is really a relatively small database. 1, 2, I'm glad to see it's using my clustered index. And 3, I don't have something that I'm going to see later on down the page, and that's a table scan. So I'm using my index. That's what I want to see happen. And overall, the performance isn't bad, so I'm good to go. One other thing to note about this, if I put my mouse over it, and I was avoiding that on purpose to kind of save that for later, it actually gives you additional information about each one of the icons on the screen. So I can see the physical operation name, logical operation name, estimated I/O costs, estimated CPU costs. So lots of additional information to help me more finely determine where my costs are and how to optimize a query. Now if I scroll down a little bit more, the last one on the page, or actually it's the second to the last, both the last 2, both include something called a table scan. Here's something that I would be looking for to eliminate. Table scans are typically costly operations. As you can see here, there was a clustered index scan as part of this SQL statement. There was also a table scan. The table scan took up quite a bit more time than the clustered index scan. And that's typically going to be the case. If you find yourself running queries that oftentimes require a table scan, that means look from beginning to end, or at least till the data is found within a table, or maybe beginning to end depending on what you're doing. If you're summing all the values throughout a table, you're kind of stuck, right? Or grabbing information scattered throughout a table, you may be in a bit of a pickle, right? But table scans are going to typically cost you more resources and more time, and they're typically something you want to avoid. And the primary way you avoid that is create a new index to eliminate the need for that table scan if possible. But that type of analysis really falls more under application developer, so you typically aren't going to delve into that too far as an administrator. You do, however, want to at least be able to identify the queries that are of interest, and that way you can communicate that to your development person. There's a couple of other tools that relate to performance monitoring. We don't cover them in a lot of detail in this video, but I want to at least give them a honorary mention here. They're covered in more detail in the monitoring video, but that's first of all the activity monitor, and then second the SQL Server logs. Both of these tools really help you in day-to-day monitoring of your system, as well as trying to figure out what are some of the things that need to be changed to better the performance of your system. And that's because really those two tasks are very closely related. So I just wanted to mention them here for kind of a complete picture, but for more information on those, you want to check out the monitoring video. So what did we cover? We talked about the SQL Server Profiler first of all. And we talked about how it's a tool you can use for stepping through your code for debugging. And our focus was using the output from the SQL Server Profiler, the output being a trace of activity in our environment, and using that as input into another tool, the Database Engine Tuning Advisor. Using the Database Engine Tuning Advisor, we can evaluate whether or not we need new indexes in our environment, evaluate whether or not an index is being used and possibly remove it, as well as other objects and other components that we can add to or remove from our environment to improve performance. We've looked at query analysis using execution plans. We generated a diagram of an execution plan before and after making changes to our environment. I talked about, we didn't really go down this path, but I pointed you in the right direction on using the Database Engine Tuning Advisor again, this time for query analysis. And it's really the same process. The only real difference is how you start the actual application. You'll bring up the query first, and then once the query is up, going to the query menu and then selecting the Database Engine Tuning Advisor from the menu, and it will actually analyze your query for you. And then last, I mentioned how performance tuning and monitoring really piggyback off of each other. When you're doing one, you're preparing to do the other, right? If you're monitoring, you're looking for anything that needs to be changed that will actually increase your performance. And as a result, some tools will easily fit under both headings. For example, SQL Server Logs or the SQL Server Activity Monitor are two tools that are covered in the monitoring video that I don't cover in any detail here, but I did want to at least mention them as part of your arsenal of tools for performance tuning your SQL Server environment. So with that, we've come to the end of this video on performance tuning. Thank you so much for watching, and I look forward to seeing you in the next video.